So welcome to this talk about multi-threaded Qt, or how to turn one problem into hopefully not multiple problem, by Bo Thorsen.
Thank you. Thank you for turning up. This is quite a crowd. I hope I will be able to not make you fall asleep. That's usually not my problem at the talks, but we'll see. So the reason that I submitted this talk was that I tend to get into fights on the Qt mailing lists about this topic. So I thought this is my chance where I just have the microphone and people can tell me that I'm wrong. So this is perfect. You have to listen to me, and any fights afterwards we can take outside. So let's see. So this is what we're going to go through today. I'm going to give you the ideas on what the different threading options in Qt are, and I'm going to tell you about when I think they apply, when you should choose each one of them, and when you shouldn't. Because there are currently about 5 different, very, very different ways to do threading inside Qt. And there are good reasons for choosing some of them and good reasons for not choosing them. So that's the idea. Compared to yesterday, this talk is going to be more technical, but I'm not going to lose any one of you, I hope. Let's see. So as you will see at the bottom here with the blue text, I have a joke for no reason other than that I thought my slides are boring, so I'll add a joke. And if you laugh, then I will assume that it's because I said something funny and not because you read the joke. So I have been around Qt since March 1997, when one of my friends showed me KDE. And back in those days, we were using really horrible user interfaces on Linux. So this was great. And I just started using KDE, and I naturally wanted to fix bugs. So I immediately broke the window manager. And then I started to do something that makes sense. So I was active in KDE until 2004 or 5 or something like that. And I've done a lot of work on Kmail. So you can blame the all the IMAP stuff on me, for example, unfortunately. I've been a Qt consultant for years. That's what I do. I help other people, other companies implement their Qt-based applications. And if someone wants me to write an application that just does something, I use Qt for it. And here's the marketing part. If you need to contact me about this, I have left business cards on the table and over there. And I hope this year there is enough, because last year I did not have enough, and I thought someone had took some competitor or something evil. I don't know. That's probably not what happened. This is a nice crowd, so we'll assume that's not the case. This is my company, Viking Software. We're a small group. I only have a couple of people working for me. So if you hire the company, there's a good chance that it will actually be me doing the code. Good or bad, I don't know. You'll have to decide on that one. So that's it. No more marketing crap. Let's get on with the real stuff. So threading. I don't know how you feel, but there are a lot of projects where I have that idea of this would be nice to park that just in a thread. Then it's not going to bother me. It's going to be happy. It's self-contained. Anything else in the application can just run without the problems of that area. That's the seduction of this one. This is when the dark side calls to you and say, yeah, go here, it will be great, you will like it, the world will be a better place, and you should try not to do that. If you have any way of avoiding threads, do it. So I have 3 rules on threads. Don't do it. Don't do it. Don't do it yet. And that's obviously nonsense, but it's sort of a joke to remind me that this really is usually a bad idea. But sometimes it isn't. Sometimes it is the only choice we have. You might want to talk to hardware where you have to do it where you just keep talking to it and you cannot do anything else. You cannot add it to the event queue or whatever you need. There might be some big calculations that you have to do and it just keeps running for hours. And I mean, it crops up. It's happening. And sometimes if you have a really CPU intensive application, then obviously we want to do it because it's almost impossible to get a computer today that doesn't have a lot of cores. Even phones have quad cores nowadays. So you want to help your users by using the entire computing power of his system. But the problems with doing this is around the tools. Debugging is one that I mentioned up here. I mean, debugging in a multi-threaded application sucks. So the first time you start saying, maybe this threading stuff wasn't such a good idea anyway. .threats comes here and I have to debug him and it's just annoying. You can single step, but what actually happens when you single step in a multi-threaded application, it's just weird. And then you have discussions on the mailing list. I see this, the last one up here, asked on the mailing list again and again, can we do SQLite calls in threaded applications? The answer is yes, if you have a very clear mutex around it, so you never have more than one thread talking to it. But it's hard to make sure that this is the case. It's hard to encapsulate the problem in a way where it's impossible to circumvent that mutex. So it gives you a lot of problems when you do this. And that's what you see when you do this. So you might not even get all the nice things that you had hoped to get, because puppies don't do what you expect them to do. I know, I have one. So, just for the last thing here, let's just try and avoid these things. Timer-based slicing is one thing that I do a lot. If I have something that can be cut up into small pieces and it's not really relevant how fast I can get them done, then put them in a small queue, make a timer, and just handle 1 to 10 of them every time the timer fires. Then the guy using the application cannot see that this happens. It looks like it's multi-threaded, but it isn't. You're using the Qt event system to avoid threats. And this is a trick, and you might even call it a bad hack, but it avoids threats, and that's a good thing. If you have the big running calculation, then everyone will say, yeah, just call process events. And whenever I hear that, I think back to the days when I was in KDE. And I assume a lot of you know who David Four is, the guy who works for KDAP. He's a brilliant coder. And I know the guys who know him know that he's a brilliant coder, so he probably won't mind that I tell this. I spent 2 days single-stepping through an application, 2 full work days. It wasn't the most fun work days in my life, but I was hunting this insane bug, and I could not realize what was the problem. And I finally tracked it down to a single place where process events was called. And David had added a comment just above it saying, it is okay to call process events here because it's safe, because whatever. I don't remember the reason. So he had considered that this was bad and might be potentially dangerous. He had concluded that it wasn't. And 2 days of debugging later, I found out that it was. And that's what happens. So this process events, that has big dragons lurking when you do this. Be careful. A guy asked me about multiprocessing or multiprocess applications, and that's an alternative. When you run stuff in separate processes, that makes debugging even worse, because you usually cannot debug 2 applications at the same time. So that means debugging is now going from bad to horrible. But the good thing is that it's in a different process, so you're really forced to think about encapsulation, modularization, and you're obviously shielded from crashes and evil stuff like that. So I mention it here, but I don't really consider it as an alternative to threads. It's, yeah. So that's it. Now we stay on threads, I promise, until I don't. So we have some tools in Qt that are necessary for this. And when you read about threading in literature, these are the classes that you will always hear about. The terms are the same, but sometimes they're implemented in slightly different ways. So mutex is the one you always use, and the one you always should use. Semaphores, for those who don't really know what it is, it's like a multiple times mutex, one you can lock more than once, sort of. Wait conditions is nice because it tells other threads in the system something happened. You have something on the queue, go do it. And then it wakes up and you do stuff. The one that always surprises people is the read-write logger, because this sounds like a good idea, right? It sounds like we'll have a read-write logger because we usually read stuff, so we only lock when we actually write stuff. That's the theory. And in very few applications, this is the case. In most applications, if you actually benchmark the difference between doing that and just locking a mutex, you will see that it's slower. QMutex is a very, very fast class. So there is a almost 95% guarantee that if you have to lock something to do writes or reads, just lock the mutex. It's going to be the fastest options you have. Read-write locker is for a very specific purpose where, I don't know, in a web server, if I had to code a web server, then I might use it, because web servers usually do more reading than writing. But for anything else, the database case for SQLite, I wouldn't even consider it. Just forget it. It's there, you can use it. The one I would like to say is this one. When you do have a mutex, you do not ever call lock on the mutex, ever. And if you do, contact me. I will administer punishment that's severe enough for you. You do a mutex logger instead. It's the only way to be exception safe. And you might say, I don't use exceptions, and your compiler will happily get rid of that assumption for you. So use mutex logger always. It's the only way to lock a mutex. And you can unlock a mutex logger again and relock it. But oh yeah, one thing about mutex. I don't know if the mutex will be re-implemented to use the new C++ threads mutexes, now that we actually have mutexes in real C++. It might come in Qt 5.7, but I don't know. It's an option now, because in 5.7 we're going to use C++ 11. So maybe. What I don't know is if the Visual Studio 2012 mutexes are good enough for this. Or that's not true. Of course they're good enough, but they might not be as fast as the one that's already implemented. So I don't know. That was a problem. It was a question I had yesterday. Will Qt use the C++ mutexes at some point? It might. I don't know. I don't care. I just use QMutex. It works. It's fast. It's brilliant. Why worry about what C++ throws at us when we have something that already works? The thread storage is another point on sort of the same system, because now there is thread local storage in C++. The idea is simple. You have a variable somewhere in a function, and this variable is specific per thread that calls the function. That's the idea. I have not once had a use case where this was necessary, but I can see the idea. Atomic storage is about storing something in an object where you're sure that you can read, test if it's set to something, and then write in one go. So there are these QAtomic integer, for example. You can use those for flags on stop the threads flags, for example. That's one thing where you mightn't use somewhere like this, but we'll see. So there are not a lot of tool classes in Qt that supports threads, but I don't think I've ever needed more than these. I might have added one more up here, which is QObject itself, with the signal slots connections that we have across threads, but I haven't because it's not a tools thing. It's not a threads thing, but it's definitely usable. So here are the 5 ways of doing threads today in Qt. You can discuss if the last 2 are different, actually, but I don't care. This is my way of thinking that there are 5 different ways of doing it. And it's actually done in the order of how they were added to Qt itself. So we had, in the early days, when I started, back when dinosaurs roamed the earth, we had QThreats and only QThreats. You could subclass QThreats and that was it. And then someone invented the idea, I love that term, that we figured out, hey, this could work this way, of worker threads. But it's actually, we didn't have to do anything to QThread itself. There was a small disaster down here. Everyone's okay. No one has been harmed, but someone please call the doctor. Oh, okay, problem solved. Doctor's not necessary. So then we added thread pools, and we got those, and those were nice to have, but no one used them. So Qt Concurrent was there to sort of solve the idea of how thread pools were really used. So that's what I'm going to go through now over the next slides. It's just going through the catalog of how the threads are used in Qt and what we do with them when it's a good idea to use one or the other. You will probably disagree with me on some of what I'm going to say now. That's okay. You're allowed to do that. You'll probably be wrong, but... So, QThread subclassing. That's the one where you can find a bunch of block entries saying, if you do this, you do it wrong. They don't open for the possibility that sometimes this is the right solution. And to me, that's just silly. Of course, this is a viable alternative when you have the proper problem for it. But there are reasons these guys write these blog entries. And I understand the reasons and I acknowledge them. The only thing I disagree with is that they say it's never the right choice. That's not true. This is what we started with. It served us well for something like 5 to 8 years. So of course you can do it. And there are a couple of places where it's good. So the one thing that makes this difficult is when you connect signals and slots on QThread subclasses. This is the problem. This is why people say don't do it. Because you are not, unless you really start going into the why of how it's done the way it is, you're not gonna know exactly which thread is gonna emit my signal. You're not gonna know exactly which slot which thread is called when you connect some slot on the object for it. And the reason is the QThread object itself sort of lives between 2 threads. The QObject thread, when you instantiate it, it actually lives in the creating thread. So when you have a system with only 2 threads in, you have the main thread, the GUI thread, and you have a worker thread. The QThread object itself lives in the main thread. And you should never, ever move it to the thread. Don't call move to thread this. Again, I will come and haunt you in your dreams if you do that. I have had customers, this is real customer code. And I cannot punish my customers. Well, I can, but that's done by invoicing. So, The reason, again, is that you muddy the waters, because when you want to delete the object itself, it has to be in the thread where you created it. So what are you going to do if you move to thread this, and then you connect the signal to destroy this? It's just going to be weird. So don't do stuff like that. So what's happening inside QThread, the object itself, when you do run, now you're in the thread you've created. So the constructor and the destructor of QThread runs in the thread that created it, but run runs in the thread that's created. And it's I don't know if I make it sound difficult. That's actually not the difficult part. The problem is then when you do the signals and slots on these objects, because each QThread object has a notion of which thread it lives in. And the Qt system knows this. So when you emit something from an object in another thread to an object in this thread, then it will go through the event loop, and magic things will happen. So you emit in one thread, and your slot is called in the other thread. That's great. It's the simplest way of doing thread-to-thread communication. But this just destroys it. Because you're in the thread, you're in the run, now you emit something, and the thread says, oh, I'm emitting from the thread that created. But you actually do it in the others, and you might even have weird crashes that you don't see. So that's a long tirade of why this is bad. And that's because these guys, these bloggers, are usually right. There are mostly, the only thing I do with this is if I have something that just does calculations. Just create an object, go do something. Sometimes I do subclass QThread just for encapsulation purposes as well. Because the good thing about doing a QThread subclass is that then I have an object which has the responsibility of what the thread does. No! Where's that doctor? Thank you. So the whole point of me going against all of those guys who want to fight me, and I'll be happy to do that, because as I said on the second slide, I actually do have a black belt in Taekwondo, so that's not a problem. Not in this crowd, usually, at least. But I agree with them almost always, but sometimes I still do subclassing. And this was the only thing we had for quite a while, until, yeah, that's whatever. In creating thread, in creating thread, in created thread. That's what I said. Moving on. Until we came up with this idea instead, worker threads. So now, instead of subclassing QThreads, we create a QThread object, and we create a Q object and says, that's the thread you should run in, and then we say go. Now we're safe, because now the signals and slots on this Q object, we know they're in the right thread. We know how to make sure that stuff happens in the right one. And sure, in the other one, you can force Qt connections, and this is much cleaner. But the one thing about this one that's not cleaner is that this is done in the calling function. So now you move away from the object where one object encapsulated that something ran in a thread, to now you are forcing the caller to do something. Naturally, you can put this in a function, and you can, I mean, there are ways to encapsulate this, but it's the only drawback I can think about on this one. If you just have a Q object that does stuff and you want it to emit signals as it's progressing for a progress bar, for example, this is usually what you do. It's the right choice, and I agree with the bloggers that 95% or 99% of the cases, this is the right choice. And it's not difficult to do. So the only thing you do is you call move to thread on the object and say this is the thread you want to work in, and then you connect the worker thread when it says the thread is now started. So the object itself, just do whatever it is the object does. And when the object is done, it calls quit on the thread. Everything is easy. But there is a simpler way if you don't do signals and slots on the object itself. If you don't need this, then there is a much simpler way, which is to use the thread pool. Thread pools are simple. The idea is we have the system instantiate X amounts of QThread objects, and then when you have an object, you just give it to the worker thread and say, here, do stuff. Exactly like I did on the other page. But now, instead of me creating a QThread, every time I do this, we reuse the QThread objects. And I had a customer some time ago in Spain, not that people in Spain are supposed to write that bad code, but they did, who did it the other way. And he couldn't see that QThread was a better way to do it, so I said, okay, let's just benchmark it. And naturally, it was much faster to do it this way, where you reuse the QThread objects, because creating a new QThread object is not the cheapest object to create, because it calls, on Linux, it calls the pthreads, I think, and on Windows, it calls the create something. What do I care? I'm a cute guy. I just create the QThread object. But it comes with a cost of creating a QThread object, and that's just what you get rid of with this one. But the runnable is not a subclass of QObject, which means you cannot, at least not immediately, just start emitting signals and slots. You can do stuff like creating objects inside there, or so on, but you cannot just. That's the one thing about this, where it might be a bit annoying sometimes. But it's really easy to do this. Just create something that instantiate the runnable and call start on the thread pool. Say, here, go do stuff. And the thread pool will delete the object by default when it's done. So you just forget about whatever happened. This is great for situations like, for example, if you have, the best example is the web server. This is the perfect example of what a web server does. The web server itself has the socket. Something connects to the socket. It says, okay, here is the new socket connection. QRunnable. Just work on this, whatever you do, and I don't need to know when you're done. I don't care. So the runnable just goes ahead and creates whatever response to the HTTP request, sends it back, and says, I'm done, and the thread pool deletes the object. Perfect use case for the thread pool. And if you ever do implement a web server, which shouldn't, because there are enough of them, then this is the way to do it. There are other cases. For example, if you have a lot of work you need to be doing on the database, for example, you know there are 10,000 things that need to be corrected on the database. Create 10,000 runnable objects, just throw them at the thread pool, it will happen. You don't care about when it happens, and if the application stops before it's done, then when you restart, there are 5,000 left, so you just create 5,000 of them, just go. That stuff like that is perfect examples of when you use the thread pool. So, some time ago, someone came up with a futures concept. And this is a really cool concept, and it's used for a lot of things. For example, Google does this. The entire Google search engine is done using this concept. I know, I went through their hiring process a while back, and I turned them down. They're not used to that. So this idea is, the first one, where I just call run, is very much like the thread pool. And of course, it builds on the other one. The thread pool builds on QThread, and this one builds on the thread pool. So we're just stacking abstraction layers on top of the early layers here. The simplest one is this one. Just call run on it. It's very close to the same idea as what you did with the thread pool, which is not surprising because it's what the thread pool does, pretty much. The one thing that this has going for it that the thread pool doesn't is that it's very easy to get a signal once something is done using the QFuture watcher. So instead of you going, are you done yet? Are you done yet? Are you done yet? The kids in the backseat way of doing testing, then you just create a QWatcher, a future watcher object, and connect to the it was done signal. Then you get a standard emit, this piece of work was done. You don't need to know that for the web service stuff, but there are other cases where I need to know when this was done. Maybe you need to start new stuff happening or whatever. Then this Qt concurrent run is a very easy way of doing that. So the next one, that's now we start getting into something that's really complicated. So this one is, the idea is we have a long array of something that you need to work on. And this array needs to be transformed. Each of the entries needs to be transformed into something else, which sounds terribly abstract. And yeah, what is he saying? I have a simple example here. And examples in this area is actually quite hard to come up with. But we have a guy sitting there going, what is the average of every student in my school? What is the, we want to calculate this. That's easy to do. You just make a for loop, you go through all of them, or you do this. You create a function that takes the ID of a student and returns the average. This is a transformation. So we have a list of IDs, and we transform this into a list of averages. That's a transformation that happens here. And what you do is you call Qt concurrent mapped on the list, and with this function. And it can be any kind of functor that is this call. It can be a lambda function. It can be a standard C++ functor. Anything you want, you can throw at this stuff. And what it returns is a future object. So in the future, this will have the value. What happens is when you call results, is that it blocks until the result is there. But the actual transformation is happening on all your cores automatically. So this just takes the problem and throws it at the thread pool, which automatically throws it at all the cores in your system. So this way, you are now going from something where you had to log stuff, you had to worry about which thread am I running in, what am I doing. Here, you automatically just use your entire machine. When you can do this, it is by far the simplest way you can ever do threading on your system. But it's not that easy to come up with a way to look at your problem and say, can I actually map this to that kind of a transformation? When you can, this is the perfect solution because it's so easy to write. The bad thing is that it's really hard to look at the documentation in Qt about this because unfortunately the Qt documentation about the MapReduce parts sucks like no other place in the documentation. It's pretty much the description of what map does is that it runs mapped. And you want to say, well, what do I give it? What happens on my list? What? And you get no help. But it is possible. And what you do is you start reading about the futures concept of how Java does it. That's how bad the situation is, actually. Or you remember that it's actually not more difficult than this, because it's really simple. And I don't understand why the documentation is that bad. It's this simple. It's not worse than doing this. This is a Q list or Q vector. I'm sure Mahmoud would say that it should be a Q vector. Someone does read the mailing lists. That has these IDs, and it returns something that is a Q vector of Q real. It's really, really simple. Now, again, you would usually use a Q future watcher on this one, so you get it, so you don't block your application. You don't want to block, because then the user cannot see that something is happening. You want to put up a spinner or whatever you want to do, or just let it do it in the background and be told when it's done. But for a simple purpose, I just ran this piece of code in Qt Creator and waited for it to finish. And fortunately, my about 20 numbers that I'd put in the list was really fast to do on my 8-core machine. So the averages came fast, but that's what you would do in a real application at the Future Watcher. Map reduced, that's the next one. That's where you do a second transformation. So the first transformation is the same. We run a function on each object, we transform it to something, and then we reduce this to 1. So in this case, we stay with the averages because it's a simple example. And what it does in the reduce is that it adds each of these entries. And it starts, when I looked at this, I said, well, what's the starting point? And the documentation doesn't say. The only thing it says is that when this mapped returns the list of Q reals, then it adds them together. So what does it start with? It starts with whatever type you have with the constructor on. And that type of construction of an integer is 0. It's the same for reals. Bools is false. If it was objects, then it would be the standard constructor without arguments that's called on this. That's the starting point for whatever you have. So it creates a Q real, that's 0, and then it adds to it. And these adds are done in the order of the list. So this is not parallelized. You can say to it, you can do it unordered, and then it can do it as the threads are finished with each calculation. But I have not been able to measure that this is actually faster. So I don't know if they've really implemented this in an optimized way, or maybe my functions working on each object did not take long enough for it to finish, so I could actually see this. But so usually when I've done this, I just let it run in the order of the list. Then I am always sure that, I mean, with the plus should be safe to run unordered, usually. But some things are not. So there could be other transformation. So this one is slightly parallelized. It does the mapped part parallelized completely. And then the transformation at the end is not done parallelized, almost. Because you have one thread that does the reduce as the parts of the thread, these transformation come in. So you have all the different worker threads working on these as you go. and then the other one keeps coming up. So if you have a lot more objects in your list than you have cores on your machine, then they will be put in a queue, and you will get them handled one by one. So the reduce function can keep adding up. So then it sort of feels like the reduce function is parallelized, but it isn't. Yeah, there's a question. He asked what thread the reduce function is called in. And the answer is it's not documented. So you cannot know. And I don't think you should care. You should assume that it can be in a different thread. I would assume that it creates a thread, worker thread, that gets the confirmation that the other threads have are done working on the mapped functions. I would not assume this to run. No, that's not true. I can guarantee you that it's in a different thread, because if you just run this, then you can continue with whatever you're doing. So that means the reduce function is run in a separate thread.
Vision, it's pretty important if you something like that.
Yeah.
Or if there isn't a constructor of arguments.
You can encapsulate this in objects if you need a starting point, because then the default generated object will be your starting point, so you can control it that way. That doesn't make it faster to go from something that's a basic type to an object, but I think it's the only solution you have. I don't think you can give it the starting point, the starting number of this in any way. Filter is a very simple concept. You have a long list of strings, and now you want to get rid of the strings that does not have my name in it, which is not an unreasonable thing to do. So the idea again is that each of these objects are called in separate threads. So the thing that you can sort of see this as a reduce that creates a new QString list with whatever is left in this. It's very close to a map reduced idea, this one. But it's faster than that. So it doesn't change the original one. You just call it on your list of objects, and it returns a new list with all the objects where the filter allows it. It's a really simple concept. And again, it's automatically blasted all over your cores. So you do multi-threading without concerning yourself with all the hassles of what this does. And all of these map reduce and filter functions are so powerful, but almost no one uses them. How many here have ever written anything that uses these functions? 1, 2, 3, 4, 5, 6. That's not a lot. We're a lot of people in here. But I hope you can see the elegance of the code in this area, of how simple it would be for some times that you can use these functions. As I said, it's not often that you can. It's not often your problem applies to this very limited set of rules that define what these can do. But when it does, it's the best you can do. The ones that I've shown here have all been the asynchronous versions, where I just say go and I don't care when you're done, or you add a future watcher. But there are synchronous methods that does the same, where you call not filter but filtered, and then it works on the list itself and it returns when it's done. There are 3 or 4 different variations on each one, and I'm not going to show them here because they're exactly the same concepts. It's just, are they blocking and are they working on the list you give it them directly, or do they return a new list? That's the different variations on these things. So, yeah, there's a question. progress bar. So if I were to do a progress bar on this one, I would probably do an object that each of these things can get access to and call I have done work and do it myself. I don't think, no, I don't think so. I might be wrong, but I haven't stumbled on it. I have never seen it, so my guess is that it's not there. But it's fairly easy to do, because you give all of them a piece of work anyway, so it's easy to just create an object that has a counter. Yeah?
Have you ever tried one of those concurrent functions from inside a worker that runs inside a concurrent function?
Have I ever tried using these inside a worker thread that runs inside one of these concurrent functions? No, I haven't, but I can guarantee you that it works. Yes? Is the input list hard copied? I don't know. The my gut thread says that it's copied. If you use the version that doesn't work on the list itself, of course. Otherwise, it's obviously not copied. But I would assume that they create a copy of it. I mean, it's free to do it with the Qt system. It's free to copy a Q vector and work on the other one. And if you don't keep the reference to the original one, then nothing bad happens. So I would assume that it's copied, but I actually don't know. It's the standard in most Qt things to copy these when necessary. For example, the for each macro, that copies whatever you're working on, which is something a lot of people don't know. If you keep the reference, you have to protect it. No, not in the ones that create a new list with the results. Well, you cannot. That brings me to the conclusion that yes, it's definitely copied. Otherwise, this wouldn't work. So, thank you. You have answered your question. So, these are the recommendations that I give. QThread, very, very simple. Almost never subclass. That's what I will give the bloggers. Almost never do it. QThread worker, that's what you do when you want to have signals and threads inside your new thread. Thread pool, that's for small pieces of work where you don't need a return value. And then you have all the Qt concurrent stuff. Use it whenever you can, because it's awesome. So, that's it. We have about 8 minutes and 10 seconds for questions, so fire away. Yes?
Can I use signals?
Can you use signals in functions passed to Qt Concurrent Run? Short answer, no, because it's a function. Longer answer, if it's a functor, then you actually could. But it's highly unusual to do it. It's not that unusual that inside the worker threads you might use signals and slots. You might instantiate Q objects in there, in the pieces of work. You might have singletons in your system that they can access and connect to. That would not be an unreasonable thing to do. But in the functor itself, I would keep that very, very short, precise, and pure C++ code. Yeah. How does it work on program termination when it's not done? That's a bad idea. But it obviously happens. As far as I know, it tries to stop running new objects and attempt to wait on the ones that have not finished until they're finished. And I think there is a number of milliseconds you can ask for it to wait on the subthreads. And if they have not been done, then they're terminated. You have been terminated. I think that's how it's worked. That's how I would implement it anyway as well. So, and these are reasonable guys, so it's... Yep. Next question. Yes? Can I clarify if it's safe to use Qt signals and slots when you use Qt Concurrent Run? It is safe. What this does is to create objects that work exactly like the worker thread examples. So it creates a worker thread, it creates a QThread, and then it gives the chunk of work to each QThread as they become available. That's what the thread pool does. So this is how it works. So inside the objects that are created, you're free to use signals and slots as you want to, because the system knows what thread the Q objects inside have affinity to. I haven't really gone into the whole Q object thread affinity situation because it's a pretty complex area, and I didn't think I would have the time for it. But each Q thread knows what objects it's supposed to be running in, and these are, it's when a Q thread is created, it automatically takes the current thread as the one it's created in. And that's what happens if you create Q objects inside these worker threads. Then they know which thread they have been instantiated inside, so they will automatically be set up as Qt connections, so you can use signals and slots between them. Yes?
Are there any disadvantages of Qthread in comparison to STDthread and the other objects, for example, STD feature and so on?
Is there a disadvantage between QThreads and standard threads and within different futures implementation? I don't think so. I think both are reasonable to use. And as long as you use any kind of futures implementation, you're probably good. Naturally, I would usually use the Qt ones because I have the Qt Future Watcher that I can get a signal when something is done. And that's what we need when we do real application with this. So I would always use it. But I don't think there is an advantage between QThreads and standard thread. I would be very surprised if the standard thread isn't implemented almost exactly like QThread on each of the compilers, because it's the obvious way of doing it. But I don't know, and I usually don't care. Once the thread is running, you're good. And if you put something in a thread, well, not in the futures concept, but if you create a thread and start that and let it run, it probably runs for some time. So the instantiation of this, how long that takes, is close to negligible. That's a hard word for a Danish guy. So I would say if there is a difference between standard thread and QThread on instantiating it, then it's probably not really relevant. Unless you do 100,000 of them, and then you should have used the thread pool anyway. Yeah? Are there interoperability issues? I don't know, because if I use threads, I'm going to stay with one of them.
Yes, but I can use a library.
You can use a library. Yes, you can. A mutex is going to be a mutex, and you should be safe even if you use libraries. Because the mutex and the threads uses the system's underlying offerings of how you do threads, always. So hopefully the library you use the same technology, and they haven't been so weird to use their own threading implementation. But I cannot guarantee that they didn't do something stupid. So you never know. Yeah?
What about nesting
you had a web server and one request resulted in something that would process the list suitable for map?
Nesting them. I would probably implement some kind of a service that's shared between the thread in that case. Something they could say, give me this piece of work, and then you're back to standard QMutex protections. So I don't think it would be difficult in any way to do that. Yeah.
Are there any tools you use to visualize what happens with threads if you have like a problem?
The question is, are there any tools I use to visualize problems in threads? No. There is a lot of frustration and pulling hair. And you can visualize that. But no, I don't know of any. The only thing that I ever do to see what's going on is that I look at the number of threads my system has. And sometimes that in itself is a clear indication of you doing something seriously wrong. For example, I had one customer where they said, this is running so slow, can you help us optimize it? And I looked at it, there were 200 threads, and I said, yeah, I have an idea. So, other than that, which is probably the most basic thing you can imagine, no, I don't know of any way to visualize what they're doing. The CPU monitors doesn't really work because you can ask the thread pool to give you any amount of threads that you want. The default is, I think it's to do one more than the number of cores you have, which is a sensible default, but you can set it to 200,000 if you want to. And I will be back to punish. More questions? Yeah. Threads and GUI testing. Unit testing. Ah, you had to go there. The only thing you can do is to unit test each thing that's running in the tests. You cannot set up a reliable unit test that starts threads and checks if race conditions happen. That's impossible because of the nature of race conditions, that you might see them, you might not. Yes, you can catch some problems, but you cannot reliably make sure that there are no problems. The only thing a unit test can do is to run on whatever work you give to a thread. So that part you can unit test, and I would definitely do that. But the actual system of creating the threads and see that they're running in the way you hope they are, I think that's almost impossible. Yeah, test it individually. I use Qtest for all my unit testing purposes.
You can run your unit test with hand, right?
I can run.
Unit test with hand, right? That's sometimes.
Yes, there are ways to run the unit test, but the whole point of a unit test, just consider the word unit test. It means you test something that's small and atomic. So it's not designed to test a full system. That's what you do clicking. Go up and talk to Frog Logic. They'll tell you how to do that stuff. I have a sign here that says stop, so I have to do that. I hope you learned something, and if not, then take one of my business cards and I will punish you with invoices.